Hello everybody. This video is about chi-square test. So in this video we will learn how to conduct different types of chi-square tests and when do we use it, how do we use it, how do we calculate and interpret the chi-square. So let's begin. Chi-square is basically a form of non-parametric test. It comes under the family of non-parametric. There are basically two major types of chi-square test. One is called as the goodness of fit. The other is the test of independence. So test of independence is basically a bivariate analysis where we are trying to see if there is any association between two variables or not. Similarly, when we have only one variable and data on only one variable, we do a goodness of fit and see how good fitting our observed data is to the expected data. Chi-square test of homogeneity is very similar to our test of independence, but we are only be discussing test of independence and goodness of fit. So chi-square test, the first type is basically from the family of non-parametric, and inferential statistics, we are trying to infer something and we want to find out whether there is a significant relationship or association between two variables organized in a bivariate table. Now this bivariate table is also called as a crosstab or contingency table, and the test is basically non-parametric. Again, like I said on the previous slide, the statistical method that we can apply in both the cases is actually goodness of fit, that is observed and expected data. Since we only deal with frequencies, that is why chi-square is required. We cannot calculate the mean, standard deviations, the variances. So that is why we refer to chi-square as a non-parametric inferential technique. So we talk of the test of independence, where we look at the absence of association between two cross-tabulated variables. This cross-tabulated variables may be presented to you in the form of contingency table. What are the key assumptions? The chi-square does not require any assumptions about the shape of the population distribution, which we see generally in case of parametric tests. So most of the parametric tests, we assume that the shape of the population is normal or the sample is coming from a large population and the central limit theorem operates. But like all inferential techniques that we have been using, it assumes that the sample is coming from a random sample. How do we state the null and the alternate hypothesis, which is also called as the research hypothesis? The research hypothesis proposes that the two variables are related in the population. So we assume that these variables are related and we test it. The null hypothesis is the mathematical opposite of the research hypothesis, and the null hypothesis says that there is no association between the two cross tabulated variables in the population, and therefore they are statistically independent. That is why we call it as test of independence. One thing that you need to note is that the chi-square test does not prove that a hypothesis is correct or not. It just provides you about how good fit the data is. Okay, so it is a data, it tells you, and the chi-square discrepancy actually tells you how big that discrepancy is in terms of the observed and the expected frequencies. Let us take the example. In this particular example, we have men, or we have gender, and this on the side we have the personality type, and these are the counts. So our alternate hypothesis or the research hypothesis is that these two variables are related in population. That means the gender and personality type is related. That is, it depends. What do we mean to say? That there is a difference in terms of males and females when it comes to the personality type. And the data is given here that through a sample, 63 men were found to be extroverted and 35 of them were found to be introverted. Similarly, 42 women were found to be extroverted and 55 of them were found to be introverted. So on this we'll run a chi-square test and I'll show you how it is done. So gender, our gender and personality type are statistically dependent. So that is what we are trying to say, that gender, this is one variable, and personality type, which is the other variable, they are statistically dependent. That means for men and women, the result is going to be different. Now, what is the null hypothesis? That there is no association between the two variables. So what do we mean? We mean that the gender and personality type are statistically independent. That means there is no relationship between gender and personality type. That is, these values are merely chance. That means men and women, when it comes to extroversion and introversion, there's no difference in terms of how introverted or extroverted men are in terms of numbers as compared to women. What is the sampling distribution of the chi-square? We get the sampling distribution of the chi-square, which is basically, it is actually what we call as the statistics that we get is called as the chi-square statistics, and the distribution that we use is called as the chi-square distribution, and it tells us the probability of getting values of chi-square assuming no relationship exists in the population. That is, which is our null hypothesis. And the chi-square sampling distribution depends on the degrees of freedom. Like in the t-test, we used to calculate the degrees of freedom. Similarly, in chi-square, we calculate the degrees of freedom. Now, how this test is done, let us have a look. So let us look at a problem. We have a contingency table, and this contingency table, on one side we have the gender, men and women. On this side, it is the personality type, which we just had a look at in the PowerPoint presentation. So these many are extroverted, both men and women, and these are the introverted. So I just correct the spelling. Spelling is slightly, I need to just add an R, so this becomes introvert or an extrovert. Now, how do we run this analysis? Now, the way to run this analysis is to think in terms of what should be, if there is no difference between men and women, these frequencies for both men and women should be equal. But we have a simple solution. We have an Excel template wherein we can just simply copy the chi-square, the contingency table, and calculate the chi-square for this and find out whether it is significant or not. So we'll just copy this data we can simply copy and we can paste it in the, but let me tell you how to use the chi-square Excel template. So we will go and open up the chi-square test. The name of the Excel template is chi-square test. We'll open it. Once it opens up, if we look at the bottom, there are three worksheets: goodness of fit, normal fit, independence. So goodness of fit we use when we have only one variable. Here we have the variable color and we have 4 colors. So this is only one variable, color, but the variable is color. That means it is varying tan, brown, maroon. So here what do we see? This is the actual frequency from some data, and this is what was expected, and we calculate the degrees of freedom. Here we are required to calculate the degrees of freedom. It is 3. Why is it 3? So the variables we have 4, this is n minus 1, so 4 minus 1, it becomes 3, and we have a chi-square statistics of 13.75, and this p-value is less than 0.05, so that this is significant. That is, the color which we expected to find, we are not finding it accordingly. Now, the important one, which we were just discussing a few minutes back, is what you call as the chi-square test of independence. So as soon as we see if contingency table, which is an output of what you call as cross-tab analysis, we'll simply copy this. We'll just copy this and we'll bring it to our chi-square. But first we need to delete this. So first we need to delete this, and then we have to go back and we have to copy this. Otherwise we'll not be able to paste it. So we'll just copy this simply and we'll bring it here. We'll input these two. I just paste it here, and as soon as we paste it, we get certain values. The chi-square statistics, this test statistics that we see is the chi-square 7.8157, and this is less than 0.05 because it is 0.0052, double zero, and our benchmark or the significance level is 0.05. That means the chi-square statistics and the p-value that has been generated thereof tells us that there is a relationship. There is a relationship between gender and personality type. That means, and if we look at the volume, we can simply see that women are more introverted and men are more extroverted. So now we know that there is a difference in terms of the gender. Let us take another example. This example is driving behavior. And on this side we have young people, and on this side we have people who are pretty old. And obviously we know that when you are young, you are more reckless. It is always said that youth is reckless, whereas when you grow older, you have a family and you become wiser. So you aren't that reckless, you are more careful. So what do we have here? Again, not the gender, but the variable is age, you may want to call it. Although these are not actual ages, but you may want to call it age. On this side, driving behavior. So driving behavior, aggressive or not aggressive. And then we counted the young. We found that 25 young were aggressive and 10 old were aggressive. And similarly, not aggressive, 75 young were not aggressive and 90. By looking at it, you may think that there must be a difference, but we need to test this statistically. The same way, we'll go back to our goodness of fit. We'll go back to our test of independence. We'll delete these values. We'll come back and we will copy this contingency table. It doesn't matter which way you paste it. Rows become column and column become rows is not an issue. So you'll come back and you'll just paste it. And once you have pasted it, automatically you don't have to do anything. The degrees of freedom is calculated, which is DF1. Test statistics is 6.7879, which is again the discrepancy. It is a big value. And if you look at the p-value is again significant, 0.0092. So it is less than 0.05. So this clearly tells us that yes, by looking at the table, we could see that yes, there could be a difference. There could be a difference, but was that difference statistically? Was it statistically different? We do this by running a chi-square, and in the chi-square we have seen that yes, there is a statistical difference because our p-value was less than 0.05, and we can say that in terms of driving, the driving behavior varies, or there is an association between driving behavior and age. And how do we conclude theoretically? How we would conclude this? That when you are young, you are likely to be more aggressive as compared to. So this could be a theoretical conclusion, that when you are old, you are more likely to be less aggressive because you are wiser and you know many things about life which somebody who's young and reckless does not know. You may have a family, and somebody who's 20 years old, 18 years old, 25 years old may not be married, may not have his sons and daughters, so he may not be really that careful, he may be a little bit reckless. So that's all about how to compute this. As soon as you see a contingency table like this, you just need to copy this. First delete the data in the Excel template, delete the data under the independence, the rows and columns which are here, you just delete them, bring in, paste your data here, and immediately you will see the result. So you don't have to do anything except, so the one in greens are the cells that can only be changed. Okay, so from Alfa Romeo, you may want to change it to whatever name, but you are least bothered. Whatever name you would want to give it, you are least bothered. You can simply just paste, simply paste this, and that's it. Thank you.